Let us develop a basic understanding on jute drawing. Firstly, let us understand the need of drawing for jute slivers. Thick carded sliver needs to be sufficiently thinned down before converting it to yarn by spinning. Moreover, for spinning a yarn of acceptable quality, this thin sliver needs to be fairly uniform and demands sufficient parallel arrangement of fibers in the sliver. Such a thin sliver is produced from thick finisher card sliver by using several drawing operations. Each drawing operation employs basically two sets of rollers: slow-moving retaining rollers and fast-moving drawing rollers, through which the slivers are passed. By this process, called drafting, the input sliver count, say C in, is converted to an output sliver of lower count, say C out, which is simply equal to C in divided by the amount of draft, the ratio between the surface speeds of retaining and drawing rollers. By the process of drafting, the fibers also become more parallel. Let us now study the drafting process for a jute sliver. Any jute sliver has few fibers of long lengths and large amount of shorter fibers. During drafting of such a sliver, it is found that when longer fibers emerge from the drawing rollers at a faster speed, they drag out from the drafting zone a lot of shorter fibers along with them, mainly due to interfiber friction. For this, a thick place is formed in the sliver emerging from the drawing rollers. Due to such undesirable movement of short fibers, there happens a shortage of fibers in the drafting zone, causing the formation of a thin place following the thick place in the delivered sliver. This is known as drafting wave, indicating alternate formation of thick and thin places in the drafted sliver. Thus, any drafting process with slivers having fibers of variable lengths induce an irregularity in the drafted sliver. In the jute drawing machines, there are moving gill pins which are meant to offer some resistance to the unwanted dragging of shorter fibers by longer fibers, and thereby the chance of formation of more amount of thick and thin places gets reduced, and thereby the irregularity in drawn sliver gets reduced. In the jute drawing machines, there is also provision of doubling of slivers, by which more than one sliver, say 3 or 4, are combined to form a single output sliver. By doubling process, the irregularity of the output sliver gets reduced due to random chance of overlapping of a thick place of one input sliver onto a thin place of the adjoining input sliver. The objectives of jute drawing are set as A. To reduce the sliver count, that is linear density, in steps by the process of drafting. B. To parallelize the fibers in sliver by the process of drafting. C. To improve progressively the uniformity of sliver by the process of doubling. For producing majority of jute yarns, 3 jute drawing operations are usually carried out. First drawing, followed by second drawing, and finally finisher drawing. For producing very good quality jute yarns like sail yarn, 4 drawing operations are preferred for much improvement of sliver irregularity before spinning. But for producing inferior quality jute yarns like sacking weft, sliver irregularity is not much important, and hence true drawing operations, first and finisher drawing, are found sufficient. Nowadays, we are observing that some mills are using 3 passages of drawings for preparation of sacking weft. Let us understand the thinning down process as executed through 3 drawing operations for converting a very thick card sliver to a very thin drawn sliver, which can be conveniently converted to a yarn by the spinning machine. Usually, the first drawing machine executes a draft between 3.7 and 4.5 and doubling of 2. The second drawing machine executes a draft between 5.5 and 6.5 and doubling of 3. And finally, the third drawing machine executes a draft between 8.5 and 9.5 and doubling of 2. Please note how the average number of fibers per cross section N bar is going down from the finisher card slivers to the finisher drawing slivers after several draftings and doublings, and finally in the yarn delivered by the spinning machine using a draft, say 16. At first, we will study the fast drawing operation. This is a screw gill type fast drawing machine. Let us now understand the drawing process as executed by this type of fast drawing machine. This is a schematic diagram of a jute drawing machine. The feed slivers are drawn through a pair of retaining rollers and a self-weighted jockey roller placed on them. Then the slivers are drawn forward by the fast-moving drawing roller and drawing pressing roller, and thereby got drafted in the drafting zone with forward-moving several rows of gill pins. Thereafter, the slivers are doubled on the doubling plate and drawn by a pair of fluted delivery rollers. Let us now observe delivery of a creamed sliver into a can. The slivers are crimped within the cream box with the help of a self-weighted lever. This is krill, a platform for placement of several finisher card rolls at the feet and unwinding them for continuous feeding. Now, we are observing that the finisher card rolls of different sizes have been kept on the crib. This is the right method for card roll feed, what is called staggered feeding. The slivers are passing through the drafting zone, having moving gill pins embedding the slivers. It is seen that some portion of the slivers are overflowing, that is, passing over the gill pins, which is totally undesirable, since these sliver portions are being drafted without the controlling action of the gill pins and thereby will cause increased sliver irregularity. We are observing how the gill pins are moved by the screws. At the front side, the gill pins are dropped from the upper screws to the lower screws by a proper cam movement. Here at the back side, we are observing how the gill pins are lifted from the lower screws to the upper screws, again by the help of a can. We are observing the doubling plate by which 2:1 doubling is executed. The slivers are being crimped and the crimped slivers are collected in the cans. Such crimping is executed to improve the cohesion within the sliver so that sliver does not break easily during withdrawal from the can or passage at the feed of the next drawing stage. The tramping action is shown here, by which several layers of the delivered slivers are made compact within the cans so that a large amount of drawn slivers can be stored in a single can. The mechanism behind the up and down movement of the tramp is shown here. The positioning of the tramp head with respect to the can is shown here to indicate that the curvature of the tramp head matches very well with the inner curvature of the can. This matching is necessary to ensure proper compression of the slivers in layers within the can and also to avoid any entanglement between the sliver layers. We are observing the collection of drawn slivers in the cans. The cans are moving in clockwise direction for some time and again moving in the reverse direction for some time. Such movement of the can helps to prevent entanglement between the compressed layers of the crimped sliver so that the sliver can easily be withdrawn from the can as required at the feed of the next stage. Here we are observing the movement of the coiler plates, which in turn rotates the can once forward and then again in a reverse direction. Here the rotational pattern of the mangle wheel is shown. This mangle wheel actually gives the forward and reverse movement of the coiler plates through a pair of bevel wheels followed by pinions. Here, wrong doffing process is being shown. Here, the correct doffing process is being shown. Here, the defective drawing pressing roller with cuts is shown. This needs to be replaced at the earliest to ensure the regularity in the delivered sliver. This is a push bar type fast drying machine. We are observing the feed of the card slivers now the movement of the gill pins in the drafting zone, and now the delivery of drawn slivers after doubling of 2:1. We are observing the design of the gill pins in the push bar drying machine. Now we will see the operation of screw gill type second drying machine. We are observing that the cans with different amount of slivers at the feed. This is again a staggered feeding. We are observing how the stop motion works in case of a breakage of a feed sliver. We are observing how the slivers are joined after a break. This is the drafting zone. The proper embedment of slivers within the gill pins or gilling is shown here. A doubling of 4:1 is shown here. A doubling of 3:1 is shown here. Wrong use of doubling plate is shown here. We are observing the sliver delivery from a second drying machine. Here we are observing that the crimping weight is missing, which is very much undesirable, since for this the appropriate crimping of the output sliver cannot be executed, which may cause operational problem in feed of the next drying stage. Now we will see the operation of screw gill type finisher drying machine. We are now seeing at the creel side of a finisher drying machine. It is seen that the sliver stop motion has not worked. Now the sliver stop motion has worked. Now we are noticing a correct splicing of sliver. We are noticing a wrong splicing of sliver. We are observing a screw gill type second drying machine. 4 persons called pickers are seen engaged in picking and cleaning operations. The machine is seen running after cleaning of the drawing pressing rollers and doubling plates. The machine is seen stopped due to roller lapping. The jam is seen being cleaned. Machine gets restarted. We are observing the piecing of a broken slider. In the second drawing machine, the running doffing is being shown. We are observing the oiling of the machine. The cleaning of a finisher drawing machine by air blowing is being shown. In the finisher drawing machine, the running doffing is being shown. The waste sliver is to be placed in a waste can. Let us now see the modern stop motion system. This is the light receiving sensor. This is the light emitting source. In this system, when the sliver breaks, the light from the emitting source is blocked, actuating a stoppage of the machine. We are observing the drafting zone with proper gilling of slivers. The presence of the pinning bar ensures such proper embedment or gilling of the slivers within the gill pin. We are observing a doubling of 2:1. We are observing the delivery of drawn slivers in the cans. Here, the cans are seen moving in one direction continuously. We are now observing the condition of the gill pins. Good condition of pins in the fast drying machine. Bad condition of pins in the fast drying machine. Good condition of pins in the second drying machine. Bad condition of pins in the second drying machine. Good condition of pins in the finisher drying machine. Bad condition of pins in the finisher drying machine. Now we will see the operation of rotary gill type second drying machine whose delivery rate is higher than the screw gill type second drying machine. The feeding of slivers is similar to other drying machines. We are observing the drafting zone wherein the gill pins are moving in a curved path and at a faster speed as compared to screw gill machines. We are observing the basic mechanism for the movement of the gill pins in a rotary gill drawing machine. The cream slivers are delivered and collected in the cans as similar to screw gill type drawing machines. Checkpoints for supervisors. Assess the shortage or excess of material at the front and back of each drawing machine. Check the general working of the machine and check the working of the subsequent process. Check whether cans are marked quality-wise with colored threads and there is no mix-up of quality. Ensure that all stop motions are working properly and take corrective measures if it is not proper. Ensure that cream box weights are properly fitted. Lapping should be attended immediately and no knife should be used. Check low production, if any, in the previous shift and find out the deficiency with respect to can shortage, material shortage, mechanical faults, power failure, etc. Check whether the cause has been attended. For breakdown in previous or current shift, find out the nature and its performance after job is done. Study shift logbook carefully and check from spinning in charge for any special instruction for change in quality on the machine or running of any sample quality. Take a general round starting from carding section in the direction of material movement to check A. Position of finisher card roll. B. Position of material at the back of the next process. C. Assess whether there is any need to change the quality on any drawing machine or to stop any machine for shortage of input or excess of output material. D. Check sliver quality for thick and thin places and wet CB percentage. Record in a notebook and if found excessive, take corrective measures. Get the machine cleaned by the operators. Care should be taken to prevent jamming of sliver on rollers and carriage bars. Sliver cans should be clean and thoroughly empty prior to start of a new doff. Floor should be clean all time and sliver waste is to be put in a waste sliver can. Ensure the waste should be as minimum as possible and weigh it regularly. Sardar should be responsible for controlling sliver waste. Visible mechanical faults are to be brought to the notice of the maintenance department. During feeding in drawing frame, staggered system is to be maintained in case of roll or sliver feeding and put new roll or can ready before it is fully exhausted to reduce the loss of efficiency. During picking, check the condition of pins and take necessary action if pins need replacement. Picking and cleaning of machines must be done as per schedule. Ensure machine guards are in proper positions.